Okay, to help my students with the interest mixture word problems, I've created an exercise that you should have in front of you. It's about Tom and Jerry. They have invested, or they are going to invest $8,500 from the sale of their ice cream. And so they're going to put some of it into an account that accrues an annual interest of 8% and the rest into an account that earns 12%. So the first thing that you're asked to do on this worksheet is to do the problem setup. So for the problem setup, I'm going to define what P1 and P2 and R1 and R2 are. Okay, well, R1 and R2 are 8% and 12%. In fact, I'm going to write this as 0.08 and 0.12. Now, I don't know how much money they put into the 8% account, so I'm just going to call that X. And I also don't know how much money they put into the 12%, but I know they're putting the rest of the money into the 12%. So I'm going to write 8,500 minus X. That's the rest of the money, and that's going into the 12% account. Okay, this is my problem setup. Now, for the rest of these questions, we're going to be writing a general equation in terms of the interest earned to represent the statement for that question. So number one says, how much must they invest at the 8% rate in order to earn $780 altogether? All right, so here again I have the word altogether. And altogether is the same thing as total. They're asking me, what's the total interest? Okay, altogether and total mean the same thing. So my general equation that represents this is that I1, the interest earned from the 8% account, plus I2, the interest earned from the 12% account, is going to equal $780. This is my general interest equation for problem 1. To actually solve the problem, I would have to do the next step, which is to substitute what I1 equals and substitute what I2 equals in here, and then I can solve for X and answer any question that has been asked with regards to this particular statement. Number 2. All right, so in number 2, it says, how much do they invest at each rate if they earn twice as much from the 8% account as they do from the 12% account? All right, so this time I know that the 8% account is going to earn more money. I'm going to have twice as much. The 8% account will earn twice what the 12% account earns. The 8% will earn twice the 12%. All right, well, how do I translate that into an equation? The interest earned from the 8% account, I1, will earn, or equals, now twice means we're multiplying by 2. So 2 times the interest earned at the 12% account. Oops. I2. All right, so here's the general equation that represents that statement. Now, this is a tricky kind of problem for most students, and they know, they eventually get to where they know that I1 equals 2I2, or some of them might think that I2 equals 2I1. Well, what I tell them to do at this point, since they're not really sure, and I always tell them to do this anyway, is to put a number in for I1 or I2 and then see what the other number is, and then see, does the right account earn the most money? For example, if we let I2 be 10 in this equation, then 10 times 2 is 20. So I2 would be 10, which would make I1 equal to 20. All right, that means that the 8% account is bigger. It's earning more money than the 12% account. And sure enough, that's what the statement says, so I know this is correct. But if I were to do that over here, if I were to put 10 in for I1, if I were to say that I1 earned $10, then 10 times 2 is 20 for I2, this tells me that the 12% account earned more money. Well, that's not what the problem says, so I know this can't be right. Therefore, this is my correct equation. That just helps the students out. All right, problem number 3. How much did they invest at each rate if they earned the same amount of interest from each account? Okay, they earned the same amount from each account. Same amount. All right, that means that I1 is the same as I2. And the way we say that in math is that I1 equals I2. So here's my general interest statement for problem 3. All right, problem 4. How much would they have to invest at the 8% rate in order to have $9,280 at the end of the year? All right, they're going to have $9,280 at the end of the year. The money they have includes not just the money that they earned, but the money that they started with. All right, so that $9,280 includes the $8,500 that they invested, as well as the money that each account earned. The interest from the first account plus the interest from the second account. So here's my general statement that represents this problem. Make sure the students understand the difference between money they have, and money earned. All right, statement number 5. How much will they invest at each rate if the 12% account earns $60 more than the 8% account? All right, so the 12% account earns, so the 12% account earns $60 more than the 8% account. What is the money earned in the 12% account? That's I2. So I2 earns or equals, I2 is the money earned, so I2 equals 60, and then more than means plus the money earned from the 8% account, which is I1. So this is my general statement that represents question number 5. And question number 6 is very similar. If the 8% account earns $70 less than the 12% account, how much was invested in each account? So this time, the 8% account earns $70 less than the 12% account. Okay, the money earned from the 8% account, which is I1, equals 70 less than. Now less than, remember, we have to turn that statement around. Less than is basically the only statement where you have to write it backwards. So instead of saying 70 minus, I'm going to say something minus 70. All right, and it's the money earned in the 12% account, which is I2. So it's I2 minus 70. This is 70 less than that. So these are the general equations that represent the statements for those problems. From this point, you would use substitution, plug in and equate whatever I1 equals, plug in whatever I2 equals, solve for x, and then you can answer whatever specific question was a part of that problem.